Good morning. We are, whoops, I hit the wrong key. To expand it, not contract it. And we'll get the slideshow started from the current slide. Even though we've already done this slide before, we're on example 2. Before we get started, let's remind everybody, this is, we're doing 6.3. We should finish it today. We'll move right along to 6.4. It's a fairly short section. If we finish this today, that means the test will be Wednesday. If we don't finish 6.4 today, the test will be next Monday. So stand by for that. Your quizzes, most of you have turned those in. Let me see how many have not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 have not turned in a quiz. If you haven't, please get those in as soon as you can so I can get those back to you. Can't return the quizzes while there's still quizzes out. But you can stop by anytime and see your what you did on the quiz to see what you missed or whatever. So please do that. Any questions before we get started on example 2? All right, example 2. Let me get the pen set up. Okay. Example 2, top of page 312, section 6.3. Solve this. X times x plus 8 is equal to negative 23. How would you proceed to solve a problem like that? Okay, you certainly can do that, and why not let's go on and distribute it as well? Because you look at this and say it's factored, yay, but that's not a 0 over there, so it's not a good yay, okay? So let's go and factor that. Okay. X squared plus 8x. You want to go and add the 23? Plus 23 is equal to 0. And I did 2 steps at once there. Does everybody see how we did that? All right. Now, that was poor planning on my part. I should have left a big old, and I think I will do it, big old gap there, okay? In the old integrity, I wouldn't have to erase. I could just pull it over, but we'll do it this way. Oops. Yuck. All right. Plus 23 is equal to 0. All right. Why did we do that? Why do that? Why do I leave a blank here? What are we trying to do? Find a perfect square trinomial. Obviously, that's not. How do we make this a perfect square trinomial here? This still won't be part of it, but the part here, how will that be a perfect square trinomial? What's the rule? Half of the 8 is 4. Okay, and as soon as you do that, this is how I cheat a little bit. We're going to write down, no, this is going to be the square of a binomial. That's going to be x, and half of plus 8 is plus 4. And then what do we do next? Take that 4 and second square. Okay, and 4 squared is 16. Okay, if I could write. And that's going to make that a perfect square trinomial, x plus 4 squared. Okay? Do it and see. But we've just added 16 to this side. Okay? And actually, I'll take back my applaud of David's suggestion that we bring the negative 23 over. We really don't want it on this side. We wish we'd have left it over there anyway. Okay? So let's leave it over there. Because what we want to do is have only the perfect square trinomial on this side and leave that minus 23 over there where it was. Okay? So this is equal to negative 23. Plus 16. because we added 16 to this side that wasn't there before, we also need to add 16 here. All right, here's Justin, all right? Good. You know, get here in time, you lose your seat. No, okay. All right. So what does that give us? Everybody see what we did there? Any questions on it? Okay. All right. Let's start back. Starting with this. This is our original problem. All we wanted to do was distribute this, leave the minus 23 over there. And there's a reason for that. Okay? The reason is we want this to be a perfect square trinomial on this side, just like that one was, and everything else on that side. Okay, so we left the minus 23 here. So we had x squared plus 8x. We took half of the 8, or squared it, made it 16. So we just added 16 to this side. We've also got to add 16 to that side to keep that equation balanced, right? So we know that as soon as you took half of the 8 here, you know this is one form. As long as this coefficient is 1. Now, we haven't dealt with these that don't have 1s yet. We're going to get there. But if this coefficient is 1, and you take half of this, write it down here. Same sign and everything. Then you square it. That makes this a perfect square trinomial. Add that 16 to that side as well. Now, this is this side. That's a perfect square trinomial. There's the square of the binomial that makes it. And if you want to check it, you certainly can do that. What's on the right-hand side? Negative what? Thought it more like 7, isn't it? Okay, negative 7. What do we do now? Several possibilities. I want you to tell me what you think we ought to do now. What suggestions? Do the square root of both sides. Okay, that's certainly the next normal step here. Square root of this and the square root of that. What does that give you on the left? X plus 4. The square root undoes the square. You're just left with whatever's inside. X plus 4. What does it give you on the right? Okay, listen to him. He's got it right. Plus or minus I times root 7. Okay? Perfectly correct in the complex number system. However, if we're living in the real number world, which I've told you, I showed you about complex numbers just because you might need it sometime in the future, but most of the time, we're not even going to go there. So what we can say, in fact, what you can see, as soon as you saw a perfect square was a negative number, you could have said, what? No real solutions, because a perfect square will never be negative. But if you take it down, that's perfectly fine. If you wanted to deal with complex numbers, which you don't need to, but if you wanted to, subtract 4 from both sides, and that gives you x equals minus 4 plus or minus I root 7. That is the answer probably they give in the book. Yes, it is. Look at that. They got it right. But if you ever run into these on a test in this class, that's no real solutions. No real solutions. As soon as you see, or at any point here that you see that I is going to pop up, stop and say no real solution. X plus 4 squared is equal to negative 7. Can't happen. No real solution. But, yes.
What determines when I know it'll be like a 7 or 5 or something like that.
All right. Here's what I think he did in his head, or maybe he had already done the scratch work. He broke this into factor that negative 7 into what? Negative 1 times 7. And what's the square root of negative 1? I. That's where he got the I. It's actually plus or minus here. Okay, ooh, I don't know what the extra line is. Okay. Yeah, that's where that I came from. If you have a negative anything here, factor out the minus 1. And if you can't factor that as well. 7 won't factor, so that gives you that. Okay. But you don't need to take it this far in this course. Maybe in a later course you will. You already know how to do it. Okay? No extra charge. Okay? Got it covered. Any other questions on that one? Okay? They also don't do example 3. So what I'm going to do here is erase all the ink. And let's do example 3. Solve this one. X squared minus 3x plus 1 is equal to 0. What would you do first? Second? Okay. Get all the x terms on one side and everything else on the other. Is that what you're saying? Okay, yeah. That would be x squared minus 3x. What would you have to do with this? Subtract 1 from both sides. You don't have to do it this way, but this is how the book does. I thought, well, I'll go on and show you this way. That's equal to negative 1, because that goes to 0. Okay? Now what? Notice I left a blank there. Why would I have done something silly like that? Because I have what? Okay, I have to make a perfect square. You're absolutely right. How do I do that? Take half of the, no, this is the coefficient, half of negative 3, and that gives you? Okay, or negative 3 halves. That's another way to say it, right? Okay, any way you said it then, 1.5 or negative 1.5, negative 1.5, or negative 3 halves. What are you going to do with it next? And by the way, now's the time I come down here and put x, because that has a coefficient of 1, minus 3 halves, or 1.5, or 1.5, however you want to say that. What's the next thing you do? Square it, and what does that give you? Say again, a little louder. It's going to be a plus, square 3 and you get 9, square 2 and you get 4. Notice it is a plus. You square plus or minus, it's always going to be a plus. But if you added 9/4 here, what do you got to do over here? Add 9/4 there too to be equal about it. You can't unbalance the equation. And that made this a perfect square of a binomial. And this becomes what? How many fourths is 1? How many fourths is 1? 4, of course. So this would be minus 4/4 plus 9/4, and that would be what? Keep the 4, common denominator, 5/4. Perfect. Now what do we do? Have a perfect square on one side and a number on the other side. Trying to get to the x. So yeah, take the square root of both sides of the equation. When you do the number side, remember to do your plus or minus. Okay? And your left-hand side becomes x minus 3 halves. The right-hand side, skip this and go straight to that. That's plus or minus the square root of 5 over the square root of 4, which is, square root of 4 is 2, okay? You can lose the radical in the denominator. Because remember, there's 3 things, that I told you this before, we haven't gotten there yet, you don't like to have. You don't like to have perfect squares and a radical. You don't like to have radicals in the denominator or denominators in the radical. Here you have a perfect square in there, you have a denominator in the radical. Do that to get it out, take the square root of that. You got it. Okay? Now, if you see one like this on the test, say no rational solutions, because we haven't done square roots yet. I've shown it to you, but at this point, all you have to say is no rational solutions. But I hope I won't give you one like that on the test. I won't do it intentionally anyway. Do you want to see what you would do after this? I think you know. What? You don't care. Okay. It doesn't matter. Huh? Okay. If you could just say no rational solutions. But I think the rest of you already know what to do, right? So that's all we have to do there. If you want to see how they got the one in the book, I'll explain it to you. All right. I've been saying as long as that coefficient of the squared term is 1, these are pretty easy. And they're all easy. These are easy too. But you just got to do another step. Here's one. 2x squared plus 12x minus 5 equals 0. What would you do first? Okay, that's what you're going to do in just a second. But let's go on and move the 5 to the other side, because that's in the way here. Normally you wouldn't if you're factoring or something like that. We're not. We're trying to complete the square. So we move that over there, and that gives us 2x squared plus 12x blank is equal to 5. Now, I thought David say, let's take half of this. Not yet. Because guess what you got out here? Yeah, you got to get rid of that too. How do we do that? How is that 2, well, undistributed, kind of, yeah. How is that 2 related to x squared? What does it mean to write them next to each other? Multiply. How do you undo that? Divide. So let's divide everything on both sides of the equation by 2. Okay? And what does that give us? X squared plus 6x blank is equal to 5 halves. And now what? Q now. Take half of the 6 and that gives you x plus 3 is going to go down here. What do you do with the 3? And that gives you plus 9. But if you add 9 to the left, you better add 9 to the right. Okay? And that's going to be x plus 3 squared. Ooh, okay. How many halves is 9? Second? No, halves. How many halves is 9? Okay? Let's say, I think in terms of food, 9 pies up here. All right, okay. 9 pies. And I cut each one of them in half. How many halves? Aha, we have 18 halves. So 9 is 18 halves, right? So this is 5 halves plus 18 halves. And we know what that is, don't we? Please say yes. What is that? 5 plus 8. Yeah, okay. Yeah, we've already done that the other way, okay. We did this so we could add our numerators because we got a common denominator. And what's that? 23 halves. Got it. And now what do we do? Take the square root of both sides of the equation. And on the numerical side, you put a plus or minus. And what can you say at this point? Well, what does this left-hand side give us? X plus 3. That's all that's left there. On the other side, no rational solutions. Okay? Once we get into doing irrational numbers, I think it's chapter 5, we'll go back and do those. But, we don't need them now. Okay? Because you can't simplify square root of 23 halves. Don't be an irrational number. You can leave it right there. Now, if you want to see how to do it, I'll be glad to show it to you. Y'all interested? You don't need it at this point. You can see how they did it in the book, and if you have any questions, ask me, but we're not doing that yet. All right, any question on this? This is no rational solution. Okay. Oh, okay. Right here. When you what I was doing was getting the least common denominator. So you can't add 5 halves and 9 apples, oranges, you know. So you need to get the same denominator. Well, the least common denominator is 2. So you got to get 9 in terms of halves. How many things? And there's several ways to do it. I think in terms of food. But if you don't think in terms of food, what you could do is say I need a denominator of 2. And this denominator is 1. 1 will go into 2. 2 times 2 times 9 is 18. That's the other way to do it. I like food better, but if you like that way, it's fine. Make sense? All right. Any others? All right, let's look at example 5. Again, these that have the radicals and the i's, I'm going to try to avoid those, okay, on the test. We'll get to those when we get to chapter 5. We won't get to the i's at all, but here we have one. X squared minus 2x minus 8 equals 0. It says solve this by completing the square. So what would you do first? Add 8 to both sides, and that gives you x squared minus 2x, that adds to 0, blank is equal to 8. You have to say blank really mean. Okay, never mind. Okay, now what? You've got the coefficient of 1, good deal. So what do we do next? Take half of negative 2, and what does that give you? X minus 1. And what do you do with that minus 1? Square it. And what's minus 1 squared? Plus 1. As you just added plus 1 to that side, what did you better do? Add plus 1 to the other side as well to keep that equation balanced. So this is going to be x plus 1 squared. That's equal to what? 9. Oh, very good here. Where do we go from here? Take a square root of both sides of that equation. Got it. And what you do to the number side? Plus or minus, okay? What's the square root of x minus 1 squared? X minus 1. Perfect. Is equal to, and what's the square root of 9? Plus or minus 3. Here are your two solutions, okay? X minus 1 equal positive 3, or x minus 1 equal negative 3. There's your two solutions. What do we do to get the x? In this equation, add a 1 to both sides. And what does that give you? I can't hear well, aren't you glad? Okay, x equal, not negative, x equal 4. Over here, what do we do? Add 1 to both sides, and that gives you x equal negative 2. There are your two solutions. Guess what this is telling you? Things come out perfectly good integers there, or even fractions there. What does that tell you? You could have factored that thing to begin with. The only way you're going to get a rational solution or an integral solution, which is a rational solution, is if this was factorable anyway. Let's go see if we could do that. Y'all didn't, it said do it by completing the square, but guess what? X squared minus 2x minus 8 is equal to 0. If you were going to factor that, what would that do? What would it be? Where do you look first? First term's x squared. What would that factor as? X times x. Where do you look next? Sign of the last term. What is that? Negative. What does that tell you about these two signs? They're different, so one's going to be plus and one's going to be minus. Now you're looking for two numbers that multiply to be 8. And since these are different signs, their difference has to be 2. Two numbers that multiply. Say again?
2 and 4.
2 and 4. And which gets the which sign? 2 positive and 4 negative. Why? Because that middle term negative wins, right? You can check this, and sure enough, that would be x squared. Minus 4x plus 2x, that would be minus 2x minus 8. Perfect, it works. Now what? Yes. Either x plus 2 is equal to 0, or x minus 4 is equal to 0. Anytime you have two entities multiply together to be 0, one of those got to be 0. What does this give you? X equal negative 2, and this gives you x equal positive 4. Same answers we got here, no matter which way we did it. Make sense? Actually, factoring's easier, I think. But if you don't see how to factor it, do this. It works. Okay? All right. And find you here. I know you're in here. Colton Turner is here. Good deal. Okay. Yes, sir. Yes, ma'am. Okay, one more time.
Like at the end right there, you have positive x plus 2, and you have x minus 4. So do you just switch the signs on when you?
Okay. I just did what David told me to. He told me I had to do what he said. Okay. No. What I do, you do is subtract 2 from both sides. Is that what you were saying? That gives you x, and this gives you minus 2. Over here, you add 4 to both sides. That gives you x, and that gives you 4. We just skipped the step. David is really lazy. You have to watch him. He's super lazy. Okay. All right. Good deal. Does that make sense? Does that answer your question? No?
What did you just say? Say it again.
Okay. I got sort of carried away here with my lines. It makes it hard to see. Okay. At this point here, whoops, let me get rid of that too. Okay. Let me get rid of these. Okay, you with us up to there? All right. Now what you do here, you're wanting to solve for x, right? That's what solving the thing means. Find that unknown, okay? So what we'll do here is subtract 2 from both sides of the equation, right? What does that give us? X minus 2 plus 2 goes to 0 is equal to negative 2. And over here you can solve for x. Add 4 to both sides. Right. And that would be x equal 4. Good deal. Good question. Excellent. Please ask. I'm skipping steps or jumping ahead or messing up. Stop me and say, how do you do that? Okay. I'll sometimes say, I don't know. Okay. He told me to. Okay. Next. Any others? Okay. That was example 5. So even those that you can factor, you can use completing the square. Why would you want to? Well, sometimes it's not clear what that factor is, so perfectly fine to use it. All these tools, if you use them right, they should give you the same answer. You have a good little concept quiz here, 6 true-false questions. I would say do those. Make sure you understand what the answer is and why. Okay, but don't expect to see many of those on the test. But still, if you got the concepts down, you're going to do better on the test. So homework exercises here. Do any of the odds 1 through 13. I believe all those we were able to do, right? Yeah. And then I'm trying to leave off those with radicals and i's. So that means I don't think any of that next section you have to do. It's hard for me to see this. It's printed so strangely. Yeah, I'd say none of that next set. But then in the next group, you can do 39, 43, 45, 51, 53, 55, 56, and stop there. All right? If you want to do 61, you can, but that's the first thing we're going to do next, okay? Because now we're moving to, oh yeah, let me get these out of the way. All right, we're moving to quadratic formula, which is section, let's see, yeah, 6.4. Got to get this out of there, and let's get 6.4 up here. Okay. It's slow, but it's happening. It's close. Not there yet. Come on, you can do it. Let's see, maybe it is there. Nope. I don't know where it went or what it's doing, but let me try it again. Yes. There we go. Yes.
We did some of them like no rational solution.
Right.
And we said we can factor them. If we try to factor them and we see we can't be factored, can we just say no rational solution that way?
Yes. If you're certain. Okay. That's one thing that completing the square or this next technique will do for you. Just because you don't see how to factor it may not mean that it can't be factored. But if you can't see how to do it and try one, either completing the square or what we're going to do next, and you do get a radical or something like that, then you know you're right. It can't be factored. But if it pops out there and you can get that, you say, whoops, yep, it could have been factored. Go back and check it. I bet you'll see how you could. But some of those really difficult ones, that might be the way to go. But yeah, if you know it can't be factored, you can just do it that way. Because if it can be factored, it's going to be rational. Okay? If it can't be factored, then it won't. Okay. Good point. All right, let's get the slide set up from the current slide. Okay, we're continuing with quadratic equations. We're not going to do much on inequalities, but let's now look at the quadratic formula. Have y'all had it before? You have? Okay. If you haven't or if you've forgotten it, we're going to go over it, hopefully do it fairly quickly. We'll use the quadratic formula to solve quadratic equations, and we'll determine the nature of roots to quadratic equations using the quadratic formula. It's a real easy way to do it once you use the quadratic formula. But we don't have it yet. Okay, now remember I said that 61, that was the last exercise in the 6.3 section on page 315. But recall that the method of completing the square can be used to solve any quadratic equation, whether it has a real solution, a rational solution, or a complex solution. It doesn't matter, it'll find the solution. Thus, if we apply the method of completing the square to this, what do we call that? Our standard form for a quadratic equation, where A, B, and C can be any numbers in the world. Positive or negative, rational or irrational, and we're not going to go into complex, but we will get to those. But any real numbers, A, B, and C, with one exception. One of those numbers. What is that exception? A cannot equal 0. Why couldn't A be 0? B could be 0, C could be 0, A could be positive or negative, fraction, decimal, rational, irrational. B could be any of those and 0. Why can A not be 0? If A were 0, do we have a quadratic equation? No, we have a linear equation. That's why it can't be. If this is a quadratic equation, A can't be 0. A, B, and C are any real numbers in the world except A can't be 0. That's the only exception. Then we can produce a formula for solving the quadratic equations. I'd like to tell you that once we do it once with that standard generic form, you never have to use it completing the square again. Would you be happy? Yeah, no. But guess what? I can't say that because there will be other instances where you will need it, but not as often. You won't need it to solve quadratic equations anymore. That formula can then be used to solve it, and you never, for this purpose, have to use it completing the square again. But you like doing it. I know you did, okay? Now, they're going to do it and show you all the steps. Let's just do them ourselves. Let's start with this form. Let me get my pen back. Okay. Start with this form. What was the first thing we did when we had a form like this? In that last set we were doing. What's that? Okay, and what do we take out of the space? We moved the c to the other side, didn't we? We subtracted c from both sides of the equation. And that left us with, I'm going to write it over here, ax squared plus bx blank is equal to minus c. Don't you like using letters? Guess what? Use them once. You'll never have to do it again, hardly. Okay. So what's our next step? Second? Yeah, you got to get rid of the 8, don't you? You want that coefficient to be 1. How do we do that? No, it is multiply. Divide. Okay, we'll divide everything. Right. Divide everything on both sides of the equation by a. And guess what else? That's the second reason a can't be 0, can it? We can never divide by 0. So there's another reason a can't be 0. All right, what does this produce for us? X squared. Next. Plus b over a times x blank is equal to minus c over a. Don't you love using letters rather than numbers? They're so much fun, okay? Next, what's our next step? Not yet. You got to get this to be a perfect square trinomial. What we got to do that? Take half of this term. That will be what? Ooh, these have letters. X plus half of b over a. Wouldn't it be that? Isn't taking half of something dividing by 2? And you divide by 2, that's what you get, right? Okay, so you get b over 2a. Then what do we do with that? Huh? Square. And what's the square of b over 2a? Plus b squared over 4a squared. And that's going to make that a perfect square. But if you added that to this side, what have you got to do over here? Don't you just love these letters? Plus b squared over 4a squared. All right. Now, I can't do this one in terms of food as well, so we have to do it the old way. All right? Before you can add these two forms, what do you got to get? Say again? Common denominator? Yes, common denominator. What would that be? Least common denominator? No, that's not common here. 4a squared. Now, how do we get this to be a 4a squared? That's already a 4a squared. How do we make this one 4a squared? By 4a. Okay, we're going to multiply this one by 4a in the denominator. But if you do it in the denominator, what did you also better do? Multiply the numerator as well, times 4a. Okay? Got it. Okay? Now, I'm going to rearrange that slightly, put the plus in front, so that'll be plus b. I don't even need the plus there. Let me leave the plus off. It's just confusing. Okay? That's going to be b squared minus 4ac divided by 4a squared. Right? That was our least common denominator. I swapped the terms, made it b squared minus 4ac all over 4a squared. Okay? Now what do we do? Take the square root of both sides. Very good. Okay, now this has a variable in it, so we'll leave that alone. This one, these all represent numbers. So what do we put in the front of the square root? Plus or minus. Okay. Boy, this is getting messy looking at it. Left-hand side, though, cleans up a little bit. What does it do? It just becomes x plus b over 2a, right? Because the square root undoes the square, okay? On this side, it's equal to plus or minus the square root of b. Okay, sorry about that. My thing just dropped on me. Been doing so well. B squared minus 4ac, that's the numerator. That denominator, though, is a perfect square itself, isn't it? So square root of 4a squared would be 2a. Very nice. All right. Now, what's the last thing we got to do? Solve for x. And what would that give you? How do you do that? Subtract b over 2a from both sides. Now I'm going to subtract it in front. There's a silly reason for that. Okay. Okay. So this goes away, and what we have is x is equal to minus b plus or minus the square root of b squared minus 4. Okay. I know, the letters are so, if you can just hold your breath until we finish with the confused test, you got it down, okay? Yeah, the letters are confused. That's it. I said, don't you love these letters? Yeah, they're like fun. Okay. But get what we got here. Over common denominator of 2a. And guess what? That is your solution. What are these a, b's, and c's? They're the coefficient of the original problem, right? When written in standard form with a 0 over there, and all you have to do is pull those out, plug them in, and you got it knocked. That's all, folks. Okay? It's so much easier with numbers, but that's what it is. All you have to do, and guess what? On your test, what can you have with you? A formula and equation sheet. If you don't want to remember this thing, write it down. Okay? What's that? Of course. Yeah. Yeah.
So we'll have an equation sheet. Do we have to make it ourselves?
You make it yourself. You don't want me to make it for you, do you? No. That way you wouldn't learn anything. I mean, if I do it, all you have to do is read it. That's passive learning. If you have to write it down, that's active learning. You get to remember it better, all right? I don't want to take that away from you, okay? I want you to have all the joy of it, okay?
How many triangles do you have?
There's about 20. I don't know. There may not be exactly 20. But, yeah. So, anyway, there's the quadratic formula, okay? Now, the next page is going to show that same thing we did, but now it's passive. This way you were doing it. But let's see what they say. Here they start with the standard form. A squared plus bx plus c is equal to 0. That's standard form for any quadratic equation. You write it in that form first, okay? Then we start by completing the square. First thing we do is subtract the c from both sides, and they show left a blank here. Then you divide by a. That gives you x squared plus b over ax is equal to minus c over a. Just what we did. Then you take half of this term, b over 2a, square it, and you get b squared over 4a squared. Add that to both sides. This is where it really gets pretty, isn't it? Okay. Then we make that the perfect square trinomial, which is already that. Well, they did everything. Oh, what they did here was this was minus c over 4a over a, and then you get least common denominator. They left off the step between previous, multiply both sides by 4a. That's where they get 4ac with the minus in front. Okay. Then they flip them. Okay. Write the side just the same. Flip those two. b squared minus 4ac over 4a squared. This is a perfect square trinomial. They waited till now. I've already written it down. Ax plus b over 2a, because that's the thing that you did here, b over 2a. As soon as you do that, I write it here. That's your perfect square trinomial. Over here is b squared minus 4ac over 4a squared. Then you take the square root of both sides. That leaves you x plus b over 2a here, plus or minus the square root of this. B squared minus 4ac over 4a squared. But this 4a squared is a perfect square, so that becomes, well, they take more steps to do it. They split them up here. Then they can say that's a perfect square. So it's x plus b over 2a is equal to plus or minus square root of b squared minus 4ac over 2a. How many times are they going to write that down? Okay, oh, and then they do one for the plus and one for the minus. That's why they did it that way. Why, I'm not sure. But anyway, subtract the b over 2a from both sides of both equations, and that gives you minus b plus or minus, and this is how I usually write it. Minus b plus or minus the square root of b squared over minus 4ac, all under this radical over 2a, as long as a is not equal to 0. Now, the point is, once you know this, and write it down, bring it with you to the test, you can use it for any standard form of a quadratic equation. No matter what the a, b, and c is, plug them in, and you've got your answer. Okay? So let's do an example. What you reckon the first thing you better do? There's a couple ways to start. How do you want to start? Say again? Okay, he was cheering about not doing the completing the square anymore, and now he's wanting to do it. Okay? First thing you do, write down what your a, b, and c is. What's your a here? No? Coefficient of the square term. 1. What's your b? 5. What's your c? 2. See how easy that is? All you have to do is plug that into the quadratic formula. What is the quadratic formula? Your answer will be x is equal to, what is that? Tell me, remind me what it is. Minus b, yeah, let's write it down. Minus b plus or minus the square root of b squared minus 4ac divided by 2a. Got it. Now we plug it in. X is equal to, like you said, minus 5 plus or minus the square root of 25. That's 5. I'll write it down. 5 squared minus 4 times a, which is 1, times c, which is 2. Okay? And all that is over 2 times 1. Okay? Because a is 1. All right. Now, I'm going to take you through slowly how I do this. Minus 5, that's pretty easy. Plus or minus, that's pretty easy. Square root of 25, got it. Now, here's what I do next. A little time out here. I count the number of minus signs. This 4 is always a minus 4. Always. These happen both to the be plus. If they weren't, count the number of minus signs. How many minus signs you got? 1. And if that's an odd number, and 1 is, then this stays minus. Okay? If that were an even number, it becomes a plus. This wasn't, it's a minus, so we're fine. Then you multiply the numbers together. 8, okay? Woo, did it again. And then you divide by 2 times 1 is 2. And this is minus 5 plus or minus the square root of 17 over 2. There's your answer, you're done. Without having to complete a square, without having to try to factor or anything else, there's your answer. Plug it in, just like the lake, right? Now, am I going to give you one like this on the test? I'm going to try not to. Because I'm going to try to avoid those radicals. But if you're trying to estimate your answer, If this was something like you had to order so much fencing or something else and you needed to know about what answer, what is the square root of 17 just a little bit more than?
16.
A little more than 4. So this would be minus 5 plus 4. That would be minus 1 over 2. So it's a little bit less than 1 half, negative 1 half. Or minus 5 minus 4 would be minus 9 over 2. So it's somewhere close to those two numbers. Yeah. I'm sorry? It looks like it'll probably be next Monday. I was going to say maybe Wednesday. I don't think we're going to finish the section today. We might finish today. I don't think so, though. So it'll probably be Monday. Okay? So this was example 1. Okay? You want to see how they did it? Now, they may have changed a little thing at the end, but, again, I'm going to try to avoid this one anyway because you haven't had the radicals yet, even though you have now. The first thing we're going to do is write it down again. Yay, I wanted to waste my time and do that. Then we identify what your A, B, and C is. That's a good next step. Make sure it's in standard form, equals 0, then write down your A, B, and C. Then once you have them written down, plug them in, plug them in. That's all you have to do. You got a little more manipulation to do, but that really gives you your answer. Okay? So you plug those in, minus 5 plus or minus 5 squared, square root of 5 squared minus 4 times 1 times 2 over 2 times 1. That's minus 5 plus or minus square root of 25 minus 8 over 2, and that's minus 5 plus or minus the square root of 17 over 2, and then they wrote the answer again in solution 4. Again, I'm going to try to avoid those with radicals. Okay? But there's your answer. Now, I know David wants to complete the square because he really grew to love that one. But, the rest of you can use this one. Okay? Makes it a piece of cake. Any questions on that? See, that's what math is all about. Finding, even though it takes a while to get there, finding the easiest way to do the problem. Plug it in, plug it in. It's pretty simple. Now, they're skipping example 2. I know you want to see 2, don't you? Let's do example 2. Let's solve this one. 2x squared plus 4x minus 3 is equal to 0. What's the first thing you're going to do? All right, find your A, B, and C. What is your A? 2. What's your B? What's your C? Negative 3. Be sure you keep the sign with it. Okay? And what do we do with those? Plug them in, plug them in. What do we plug them into? X equal? And what is it? Minus B. But I'm going to make you say it over and over until you got it down, okay? Square root of, you're lazy, I understand, okay? B squared minus 4, A, C, all over 2A. Remember that 2A is underneath that whole thing, and all those, that B squared minus 4AC is all under the radical, okay? Now we plug it in. And what does that give us? Minus 4 plus or minus the square root of. What's that? Did I get it right? Okay, 4 squared minus 4 times 2 times negative 3. Okay, all over 2 times 2, which is 4. Okay, so that's going to be x equal minus 4 plus or minus the square root of 16. Say again? I can't hear. I can't hear. Plus, okay, yeah, I couldn't hear you. Okay, plus 24. All right, he's way ahead of me. Okay. Now, notice what did he do here? Or what I like to do? Count my minus signs. How many you got? 2. That means it's going to be plus. Even number of minus signs always is plus. Odd number of minus signs always minus. That's a plus 24. Got it. And over 4. Okay? So this will be minus 4 plus or minus the square root of 40? Is that what you said? I thought so. Okay. Over 4. Okay. Now, huh? Now, if that were a perfect square, we'd have our answer. Since it's not, we'll wait till we do chapter 5 and then we'll figure out that as our answer. But guess what? That actually is an answer. If you had a calculator, you could plug it in. The book's not going to give you that answer. It's going to do something else. Remember what we always look for if we had this? Inside a radical? We don't have to know this yet. We're going to do it later. Perfect squares in there. Is there a perfect square hiding in there? What is it? 4. Yeah, 4 times 10. 4 is a perfect square. Pull that out. 2 times the radical 10. But we're not going to go there. You don't have to mess with that. All right. Did that? I see people moving around strangely. Does that mean we're out of time? Huh? Time to go. Oh, how could it be? Okay. Let's see what we can do. That was example 2, wasn't it? We will start next time with example 3. Okay. And hopefully, I think we will finish next time. Okay. Homework exercises. Just about all of these have radicals in them. I'll give you those that don't. 29, 31, 33, and 37. This is on page 322. Let's see if I can do any more. Second? 322, page 322. Okay? I don't think we're at the place yet to do those, but if you want to, you can try 45 also. That'll give you also. Thank you. All right, good deal. All right, next time we'll try to wrap it up so we'll be ready for the test on Monday. All right?
I have a question. Don't close that.
Okay, I won't close it down yet. I would suggest one, yes. Makes it easy. Okay. So,
It's probably a really silly question, but
no such thing.
it turns into a -4 just because that's how the formula is written, where it says -b.
Yeah,
Okay.
no, negative 4AC. That's always a -4. See right here, it's always.
Oh, no. I mean the very first. The part, yeah, where it says -b.
Oh, here it's negative B. Yeah, it's always
Just
a
because
minus
it's
B.
-b.
Whatever B is. If that B has been a -4, then that changes to a positive 4. It's always
Okay.
the opposite of B. Yeah. Good question. Okay? Good deal. Yes?
So, when we have the test, what would the test have?
I'm sorry again. Say it.
When we have the test, what the test gonna have?
What we've been doing. Okay, approximately the first page of the test is going to be a lot like the quiz. Not the same questions, but similar. Okay?
So we're not gonna get a quiz for this?
No, we don't have time. I mean, I'd give you the quiz, and the next day we have the test, so we wouldn't have time to grade it and stuff like this. So no, the last 3 sections, you just use your homework exercises for that. That's a good thing to study. And ask me questions, yes. What's that? No, that'll be the one coming up. Probably.
Accident.
I'm sorry.
Yeah, I broke 2 ribs.
Yeah. Yeah, those are painful. Yeah. All right.
Reading was.
Yeah, exactly. I won't make you laugh too much. Okay. All right. Just kidding.
Reading was a problem.
Yeah. Sleeping also is not easy.
Yeah. Do we have Air Force ROTC?
To have what?
Air Force
No, we don't have any ROTC. I don't know if any 2-year school does, but
Oh,
4-year school.
Shelton does and all.
Oh, it does?
They go to Alabama, but I didn't know if we did. I was looking up on the internet to say we did. And I know Shelton, they go to the University of Alabama, and then Jeff State, they got it. They go to
Really? I didn't know they had it.
They go through another college. What's that college
UAB?
called? Sanford. They go through Sanford. Yeah, we don't have one. They go through
Oh.
Sanford too.
Oh, I see.
So all of them go through Sanford. I
Okay.
just wondered if we had it, because I was looking up online, and it said we did. It said Austin State Air Force ROTC. So I was wondering.
We haven't since I've been here, so maybe they did a long time ago.
Uh,
But yeah, they haven't had it since I've been here. Now maybe they're planning to get it, but they sure haven't told us that yet.
yeah.
Yeah.
Hey, Mr. Powell.
Yes, sir.
You said the test gonna be 3.4 through 3.6,
Right.
maybe 3.7. nothing on 6-1, everything on 6-2, 6-3, but nothing on
6-4.
6-4.
2, 3, and 4, the one that we're in now.
Okay, now we're doing 6-4, so that's 6-4.
Yeah. Now, the only reason we did 3-7, yeah, is that there's some on the final like that.
Okay.
I don't think I'll ask you any on the test like that. I hope they're not, but if so, they're just like 3-6. It's just a little more complicated.
Okay.
But the final, I have seen a few occasionally that look more like 3-7 than 3-6. So I usually skip those. I mean, include that just so you'll have that.
Yeah, I was trying to make sure Shay knew since she asked the same question I asked you last time.
Right.
I wrote it down.
Okay.